All right, so in this problem, we're trying to find the potential difference between points P and Q in this circuit. We're trying to find out which point is at a higher potential, P or Q. We have this circuit with 4 resistors in it. There's 7 amps of current flowing in from the top, and then that current's going to split. So we're going to have some of the current go down this way and some of the current go down the other way. It might not be an even split. It could be 2 amps and 5 amps. It could be 1 amp and 6 amps. We don't know yet. All we know is that the 7 is going to split down those 2 branches. Each of those branches has 2 resistors in it. I've called the 10 ohm resistor and this left branch R10, and the 5 ohm resistor and 10 ohm resistor, the 5 ohm resistor there I called it R5. And that's the left branch. And the right branch we also have 2 resistors. R2 here is the 2 ohm resistor, and R18 here is the 18 ohm resistor. So, to organize circuit problems, I first like to use a color coding technique where we code all of the parts of the circuit which are at the same electric potential. And because the copper wire is a perfect conductor, that'll be all parts of the copper wire that are connected without getting interrupted by some sort of resistor. And so I'm going to call the top part of the circuit, I'm going to highlight in yellow here, and every part of this wire is at the same electric potential value here. So all of that's one electric potential value. I'm going to grab maybe this green color, and all of the bottom here is at a different electric potential value. A is the highest electric potential in this circuit, and then B is the lowest potential electric potential in this circuit. So we're going to think of electric potential as being sort of like the elevation on a hill, and the electric current is the stuff rolling downhill. So just like a ball rolls from higher elevation to lower elevation, electric charges or electric current will flow from a higher electric potential to a lower electric potential. And so the yellow thing in there is the highest potential, and the green shown here is the lowest potential. Potential is a relative value. Just like with elevation, you can choose an arbitrary place to be your 0 level for elevation. We usually choose sea level for that sort of a map, but for a circuit, same deal. We can choose any 0 potential value we want because all that matters is the difference between 2 levels. So I'm going to choose to call green the lowest potential my 0 volt electric potential. Now we don't know what yellow is yet. All we know is that it's higher because the current is flowing down from yellow to red. All right, so we've got 2 more electric potentials. We have this part of the wire here where point P is, and we have, let's use this nice pink color, this part of the wire here where Q is. And now the potential value for P is something between that of the green and yellow part of the circuit, and the potential value for Q is also somewhere between the green and yellow value. And now our goal is to figure out what it is. What would be a good next step? A good next step would be to reduce this down to an equivalent circuit of just one resistor. An equivalent circuit is the one with the same potential difference and current value, but it's just one resistor instead of 4. So what I'm noticing as I try to draw an equivalent circuit, what I notice is that everything in the left branch goes from, those are 2 resistors in series, and everything in the right branch is 2 resistors in series. So for the left branch, I can find an equivalent resistance. I'm going to call it RL for left branch, which is R10 plus R5, which is 10 ohms, plus 5 ohms, or 15 ohms. And for the right branch, I can see that I'm going to be, for the right equivalent resistance, R sub R, I'm going to have this 2 ohm resistor and this 18 ohm resistor added together, and that's 2 ohms plus 18 ohms is 20 ohms. Cool. So the equivalent circuit to the one shown above is a circuit that looks something like this. Where point A is still here, point B is here, but we've reduced it down to one resistor RL and 1 resistor RR. For our potential color coding, point A is still at our yellow potential value, and point B is still at our 0 volt green potential value. And now, when I look at this equivalent circuit that I've drawn, maybe I want to call this equivalent circuit 1, because we're going to do 2 of these, I notice that the color on the top of the left resistor is yellow, and I notice that the color on the bottom of that is green. And it's the same for the right resistor, yellow at one end, green at the other. And when 2 resistors have the same potential difference across them like that, we would consider those to be in parallel. And so now we can add these two to get our second equivalent circuit, but that equivalent circuit is in parallel. Equivalent circuit 2, therefore, is just going to be a 1 resistor circuit, REQ. That EQ stands for equivalent, where now this is the green 0 volt end, and this is point B. And this is the other end is our yellow, point A, right there. And we're going to use our parallel circuit equation to find that value for the equivalent resistance. This is written a lot of different ways. One way to write this equation is the equivalent resistance is 1 over the equivalent resistance from the left branch plus 1 over the equivalent resistance from the right branch, and then we invert all of that. So, in other words, that equivalent resistance is 1 over 15 ohms plus 1 over 20 ohms, and then invert all of that. And so, is there a nice common denominator to do this without a calculator? Let's see, I think 60 is going to be our winner. So this is the same as 4 over 60 ohms plus 3 over 60 ohms. And then we invert that, is the same as 7 over 60 ohms. And that is 60 over 7 ohms. Plugging 60 over 7 into my calculator, I get a value of, let's see, 60 divided by 7 is 8.57 ohms. So that is the equivalent resistance of the whole circuit. And I know that there are 7 amps of current running through point A and then coming out point B, because charge is conserved. What flows in at one end must flow out the other. And so I know this equivalent resistance. I know the current, so I can find the potential difference across A to B. So the delta V, the change in potential from A to B, is going to be the current at A, that's 7 amps, multiplied by the equivalent resistance. This is often called Ohm's law, but really it's just our definition of electrical resistance. So delta V, the change in potential from A to B, is going to be our 7 amps of charge flow multiplied by our 8.57 ohm equivalent resistance. That potential difference from A to B is, if I multiply that resistance times 7, I get 60 volts. That makes sense because it was 60/7ths of an ohm. All right. So, potential difference from A to B, 60 volts. And if I set my green potential value at B to be 0, that means I can set my potential value at A to be 60 volts. And that's a difference of 60. All right, so that's pretty cool. What can we? So now that we know the potential A, we can work backwards now to figure out everything we need to of the original circuit. So we've looked at equivalent circuit 2. I'm now going to back up to equivalent circuit 1. What I now know is that this is 0 volts, and this is 60 volts. And I can figure out how much current goes through each individual branch using the same process as before. So this is additional math now to find the current through each branch. And so rearrange delta V equals IR. That's going to be I is delta V over R. I used IL for left and IR for right. Delta V over R. This is resistance right on the bottom and resistance left on the top. And the delta V, I can see yellow on the top and green on the bottom for both resistors. So it's the 60 volt potential difference for both of them. And so I'm going to plug in my 60 volts divided by that left resistance we said was 15 ohms. 60 divided by 15 is 4.0 amps of current flow. And then 60 volts divided by 20 ohms, I have 3.0 amps of current flow. And so I now know, going through this left branch, I have a current of 4 amps. And going through this right branch, I have a current of 3 amps. And that makes sense because I originally had 7 amps flowing through, and that 7 amps splits to go 4 to the left and 3 to the right. And then that will merge back together, and we'll have 7 amps coming out the other end. So that's the direction. So that's the current flow. 4 amps through the left, 3 amps to the right, and we know that it's flowing from top to bottom based on how the original problem was posed. All right, so I now know the current going through each individual branch. We can now back up to the original circuit and use this information to find the potential value at both P and Q. So if we back up to our original circuit now, in fact, I think I'm going to copy paste it and move it down below. I think that will help us quite a bit. So if I grab this and how do I do this? I forget. Copy, then we'll scroll down to the bottom here. Let's click there and paste. Whoa, hello, I don't know why it's there, but that's okay. We can move it. And so based on what we've done so far, we know that, hold on just a second, let me make things look nice. All right, so based on what we've done so far, we know that the left branch has 4 amps of current running through it. And it's a continuous branch, so even when we go back to looking at the original circuit, it's still 4 amps flowing through each of the left components and 3 amps flowing through each of the right components. And with a current and potential value and resistance values, I should be able to find potential differences. I know the yellow corresponds to 60 volts now, so let's include that in our picture as well. So what I'm going to do is I'm going to find the potential drop, the drop in energy from A to point P. And the way I'm going to do that is look at the current going through the left branch multiplied by the resistance going across the 10 ohm resistor. Because the 10 ohm resistor is the circuit element that has the potential at point A at one end, the yellow, and the potential at point B, the blue, at the other end. And so when I plug in some values, I have 4.0 amps multiplied by 10 ohms. So that is a 40 volt drop. And so I know that we start at yellow at A at 60 volts, and then across the 10 ohm resistor, the energy drops, or the energy per charge drops by 40. And so this blue part of the circuit must correspond to a potential value of 20 volts. I'm going to follow the same process going from A to Q now. If I look at the potential difference from A to Q, the current going through the right branch, and multiply it by R2, because R2 is the circuit element which has the yellow A at one end and the pink Q at the other. And when I do that, the current there is 3.0 amps multiplied by a 2 ohm resistance, and that gives me 6 volts of potential drop. And so I know that the yellow is at 60 volts. I know it's going to drop 6 volts across the yellow, so that pink must correspond to a potential value of 60 minus 6, which is 54 volts. And so the pink value is at a potential of 54 volts, and the blue is at a potential of 20 volts. And so that should mean that the potential difference across R5 is 20, and that the potential difference across R18 is 54, because they both have to drop down to 0. Let's do that as a quick check. This isn't necessary to answer the question, but it will be helpful to check that we did our math right. If we look at the potential difference from P to B, that's a lowercase b, that'll be the current through the left branch multiplied by the 5 ohm resistance, and so that's 4 amps multiplied by 5 ohms. That is 20 volts. So that's a good check, because going from blue 20 down to green 0 should be 20 volt drop. And if we look at the potential difference from Q to point B, so now we're looking at the right side of the circuit, so it's the current through the right branch multiplied by the 18 ohm resistor. That's going to be 3.0 amps multiplied by 18 ohms. When I do 18 times 3, that's the same as, what is that, same as 9 times 6, which is 54. So that's a good check too, because now we know that pink from pink to green is a 54 volt drop, which is consistent with our math we have. So all of that looks good. And now finally we're ready to answer the question, what is the potential difference from P to Q, or Q to P? How is the question phrased? I'm going to scroll back up. It just says between points P and Q. So I'm going to choose to do a potential raise. It doesn't really matter. The potential difference from P to Q is the potential at P minus the potential at Q. And that potential at P corresponds to our blue value. And that potential at Q corresponds to our pink value. And so when we do this math, that potential difference will be 20 volts minus 54 volts, which is, negative 34 volts. And since it doesn't say if we want from P to Q or Q to P, I'll just give the absolute value of that potential difference as 34 volts. And there is the answer. We can also look at our diagram, and we can say that that Q is at a higher potential than P, because 54 volts is, since the potential at Q relative to B is greater than the potential at P relative to B. All right, and there we have it. There's our answer to the question. Quick recap of the process we went through. It was sort of a working forward and then backwards process. We started with the full circuit and color-coded our lines of equal potential. We then reduced it down to an equivalent circuit by first dealing with the individual branches to get a single parallel circuit, and then using our parallel equivalent resistance formula came up with a single resistor circuit. And from there we were able to work backwards to find the potential difference across the whole circuit, which was 60 volts. And then we could look back at our circuit 1 to find out how much current went through each branch. And once we knew the current through each branch, we could look at the full circuit and figure out the potential drops across the individual resistors in that circuit. Once we knew those potential drops, we were able to measure the difference in potential across 2 points in the middle of that circuit. I hope this helps. Let me know if you have any questions.